Music theory! Why building scale shapes with modal distances is objectively better than using scale degree intervals. Introduction. In this section, we focus on the intervals or modal distances found within each scale or mode. In other words, in a prior section, we talked about intervals or modal distances in general. Now looking at just those found within the scales and modes, allowing us not only to build the scales and modes by intervals or modal distances, but also get the flavor of them, allowing us to compare and contrast the modes and the scales. Goal, objective, show how modal distances offer more clarity and precision than scale degrees when building scales, although we will be looking at both scale degrees and modal distances, comparing and bridging the gap between them. We have the same analogy, the fretboard as the planet. We have our fretboard mapped out as though we're from space, frets 1 through 6. Then the strings on the left-hand side, we have our B note landing on a continent, remembering that as the world spins, that would be analogous to us playing in different keys. We have 12 degrees of rotation that we're going to be assigning based on the notes in the musical alphabet, noting now that the B is no longer on the continent, which represents those notes that we want to be playing. That means that we want to be visualizing the equivalent to the continents, which are not actually the letters of the fretboard, but are the relative positions. They're the modes, or they're the Nashville number system. In other words, if we have the shape, which is oftentimes how guitarists in particular visualize the fretboard, one of three main ways to visualize the fretboard, the important thing is the relationship between the shape. So in this case, for example, the relationship between the E and the B is important here, but I don't want to name it as an E-B relationship, because if I play in a different key, now the shape has moved up. The important relationship is between the F and the C. Now it's moved up here. So what I would like to do is memorize the relationship by shape, which most guitarists do by breaking the guitar up into 5 shapes or using a caged type system. However, as we do that, we also want to have some kind of naming convention as well. So we'll talk about that in a second. So there's 3 ways to visualize scales on the fretboard. So we have the scale shape, which is particular to guitarists. This concept applies to other instruments as well. For example, the piano. But the piano is laid out in one linear structure. So the visualization that people will naturally tend to might be a little bit different than the guitar, which has a grid type of format. So memorizing fretboard patterns without much theoretical anchoring. That's great. This is one of the things that attracted me to the guitar. I like patterns. I like being able to work in the patterns. However, limiting yourself to visualizing it just this way is not optimal. We can also work out the positions and the shapes, or build the shapes with what I would call the formula, which is whole, whole, half, whole, 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 half. However, that is as though we just went from the top of the major. You could start from any point in the formula. So if I start here, it would be whole, half, whole, 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 half, whole. If I start here, it would be half, whole, 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 half, whole, whole. So the formula gives you using whole and half formulas based on major scale layout. So we can also then use distance from the modal root. This is our approach this time, treating the mode as the center and measuring modal or note distances from the fixed point. So we'll get more into that shortly, but one reason this is a great way to be visualizing the fretboard is because that's also how you build chords from a conceptual standpoint. You look at the distances between the notes. That is, in essence, what we're doing as well when we build a shape on the guitar by the distances from the root of that shape within the scale. So this is another idea of the fretboard shifting around like the planet shifting around. Remembering we have a naming convention similar to the fretboard from space, which isn't moving with the planet. That is the notes. But once we decide what frame of reference we want to visualize the planet within, we then want to name it by the continents, not by the notes. So in other words, This fretboard is currently showing all of the notes that are in the A major. There's a collection of 7 notes in each of our collections of notes. We have the naming convention of A to F sharp here, or a 1-10 if you want to number the notes. But I'd rather, once I determine the shape I'm in, call it an Ionian to the Aeolian relationship, or Nashville number system, a 1-6 relationship. Why? Because then that moves up. So if I move it up, then now the A is in a different continent. So now it's in continent number 7. The important thing is now this shape, Ionian to Aeolian. The continent relationship remains the same. That's going to be the same in the 3 ways that we build this shape. Either the shapes move themselves from a caged system, like moving the open positions up, for example. It also will remain the same if I build this shape by the formula, whole, whole, half, whole, 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 half, and if I build the shape by intervals, which is our point of focus now. Now you can see this note is no longer even relevant. It's kind of like in the ocean. It's a pass-through note. This is the relationship that we have been focused in on. And if I go up again, this is the collection of notes that we are typically working in. So in other words, with our analogy, we're imagining the fretboard as basically the globe. The globe is spinning around, and we're looking at the collection of 7 continents. We need to pick then the collection of notes that we're going to work in. We typically work in the 4th degree of rotation, which is the collection of 7 notes around the C major. But as you can see, the shape moves up relative. So all of the intervals will still work as we go to different positions. So you can see that this position now, this is what we were looking at before, which you might call position 1, or from a caged system, a G-shaped position. And so now it's moved up here, now it's moved up here, now it's moved up here. So the relative continent positions is the way most guitarists in particular, but the same concept works for any instrument, including the piano, although it's not as symmetrical because of the different sides of the key. But the concept, I think, is the best way to visualize any instrument. So that means when I learn the intervals, I want to memorize them in a way that will help me to navigate the fretboard through all of the 12 different rotations of the fretboard, all 12 keys, all 12 collections of 7 notes, as well as being able to go from each position within those collection of notes between the modal centers. So the compass method of mode building then. How would we want to visualize this to optimize our ability to memorize the fretboard as quickly as possible? So like drawing a circle with a compass, we pick a center modal node and sweep a consistent path around it. So in other words, if we're trying to build a scale from a particular point, most of the time we're going to think about that one point and then we go to the right or up or clockwise. But remember that you can actually go counterclockwise as well. It's kind of like going around a racetrack. So we want to be able to go both ways on the track, which is on a fretboard, similar to a compass where you draw a circle with, you put the pen in the paper, and then you draw the circle around it. In our case, the shape is not a circle, but if you're on the fretboard, you have the going forward shapes, which are going to be to the right of the fretboard and down towards the skinnier string. And then you have going the opposite direction, which is backwards on the fretboard and going up towards the ceiling. So this can be done clockwise forward up the scale or counterclockwise backwards on it. So the fretboard equals the globe. Each mode equals a continent. Non-modal tones equal oceans. That's going to be our layout. So we're memorizing or visualizing the fretboard, typically using the collection of notes around C major, but remembering that the same relative positions work just like copying and pasting the entire shape for all 12 collection of 7 notes. And we're going to say that these are going to be the destination continent locations. The ones that don't have anything in it are going to be the ocean, the pass-through locations. We still use them, but they're not the ones that we hang out on most of the time when we're playing in a particular key or a particular song, which we're always doing. We're always in some kind of context. So now instead of visualizing this shape, which we said that we could build just by shape, you're just going to memorize this from the caged system and see this particular shape. Or you can build it by the formula, meaning if I go here, I can say whole step is to here. Why is whole step to here? This is hard for guitars because we don't see the distance between the strings because we just learn it by shape. But you can see from here to here, that's the same note. There's a 5-note distance between the strings. So because 1, 2, 3, 4, 5, right? So this is a whole step to here, whole step, half step, and then this repeats over here. So whole step to here, whole step to here, and then whole step to here because this repeats over here, whole step to here, and then half step. So you can do it by formula, but we're now going to imagine like this is the center point. If that's going to be then the center point, I can also measure all the distances from that center point. So I can go forward to here and then 2 forward. Going forward on the guitar is this way, clockwise, or down. Those are going clockwise if you think about it, going around the track. Going backwards or going up is the counterclockwise direction. So I can build this same shape from a particular point by interval, which is a great practice to do because that also helps you with your chord constructions, to actually visualize and understand the chord construction beyond just building a bar chord from the top 2 strings. You can build the chord from the bottom string, having inverted chords, right? So we'll talk more about chords in a future section. So units of measure, modal versus note distance. Modal distance steps between modal nodes continent to continent. So in other words, I'm going to make up this new term, modal distance, which is in essence the same as the scale degrees, but the scale degrees are off by 1, which causes all kind of problems. So even if you use scale degrees, just realize they're kind of like off by 1. So note distance, total half-step distance, including oceans. So we have 2 units of measure on the fretboard that we are typically working with. We're going to have 1, the modal distance, which are equivalent to scale degrees, except scale degrees are off by 1, which in our analogy would be like going from continent to continent. Then we have our note distances, which would be like going continent and ocean, including the oceans. So if I'm going on vacation and the whole planet was going around the block, instead of having a 3D globe, it's going around a block, then I would be saying, I'm going to go 3 continents up to whatever, to Dorian, to the Phrygian continent. I'm going 3 continents up, right? You might not say the oceans because the oceans are the things that you have to pass through to get to the continent. They are not the important thing. But then to get there, you want to define the total distance, including oceans and continents, which would be the notes. That's basically what we're doing when we're building the scales, which we'll see in a second. So scale degrees equal modal distance with an off by 1 labeling error. So people get upset when I say this, but there's an error in the whole convention that we're using with scale degrees. They're off by 1 from a measuring distance. And it causes all kind of problems. You should be measuring from that point, not counting that point within the measurement. And we'll see the problems that happen with it going forward and also not being able to go in the negative direction. We can't really go backwards or counterclockwise as easily because the scale degrees kind of get messed up because of the off by 1 and naming convention problem. So we will bridge the gap and we'll learn to use the tools that we have as efficiently as possible, as well as possibly introduce more efficient naming conventions. So modal distances are inherently directional and symmetric. So modal distances, if you were to build it from scratch, having all the tools you have today, people would build something like a modal distance. An engineer or something that's building a system right now with all the stuff we know would not build it the same way. I mean, that's just the way it is, right? And it would be easier to learn it the easy way, right? And then bridge the gap to the current system so that you can better communicate, so you can understand exactly what is happening. Okay, so for example, if I'm on the Ionian node, we're in the collection of notes, 7 notes around the key of C. I'm on the Ionian node. We have 2 measurement conventions. When we're building our scales, we're always asking the question, hey, what if I go up 1 continent? What's the total distance to get 1 continent up? Now remember, this whole grid looks confusing, but you can basically break it down to a circle going clockwise or counterclockwise, everything to the right and down directionally is going in the clockwise direction, like a number line going up, and everything going up towards the ceiling and back towards the tail of the guitar is going in the counterclockwise direction. So we're basically saying if I go one continent up, then what's the total distance? One continent would be one modal half step up. One modal half step up would be equivalent to the second scale degree if I made this the 1. What's the total distance in continents and oceans to get one continent up? 2. It takes 2 to get there. What if I go from the Ionian to the Phrygian? Well, that would be 2 continents up, which would be 2 modal half steps up, which if we're off by 1, which would be the third scale degree if I make this to 1. And so how many continents and oceans does it take to get there? 1, 2, 3, 4. It takes 4. What if I go up from Ionian to the Lydian? An IY modal range, a 1-4 modal range. So I want to go on vacation from the Ionian and I want to go up 1, 2, 3 continents up, which would get me to the Lydian. So what's the distance to do that? That would be 1, 2, 3, 4, 5 distance. And then we can compare and contrast these to what if I was on the Mixolydian and I wanted to go up 2 continents. Is it going to be the same distance in terms of oceans and continents in terms of notes? What if I went backwards, which many people have a problem with? So we'll spend a lot of time on that in our practice problems. So asking the right question. So if I want to go up 1 mode step from the Ionian to the Dorian, how many notes away is that? That's basically what we're doing with the scales. Now remember, the scale degrees are all off by 1. So if I say that it's the second scale degree, that means we went up 1, right? But if I say it's the third scale degree, I went up 1. It would be better just to say whatever node I'm on, I'm going up this number of modal half steps, equivalent to this number of continents, without having to make the continent that you're on the 1. So how about 2 modal steps to the Phrygian? How many oceans and continents would that be? What if I go back 1 mode step? So remember, directionally counterclockwise becomes a problem with our scale degrees, but we need to figure out some system to go counterclockwise because I want to be able to go counterclockwise. If I'm going to the continent, the Locrian continent, I don't want to have to go around the block. I want to take one step backwards instead of 7 continents 4. So the modal modal allows us to ask and answer these types of questions more intuitively. So remember, the idea would be if I'm going from each of these continents going forward, the question is, I want to go 2 continents forwards. What's the total distance in continents and oceans? And I can go backwards from any of the continents, noting that I don't have to make this continent, for example, the 1 that way. If I want to go 2 continents forward, that would be 2 modal half steps forward. From a scale degree standpoint, it would be the third scale degree, which forces you to think about this as the 1. I don't want to think about it as the 1. I want to think about it as the Mixolydian continent, which from an absolute numbering system would be the 5. I don't care if I'm playing in Mixolydian, Ionian, Dorian. If it's the same 7 notes, I want to keep that continent named number 5, Mixolydian, right? I don't care where I am on the map. I'm not going to rename the location I'm on just because I'm on that location. It's not the most important point in the world just because I happen to be on it, right? I know we try, but mode comparison, major modes. So then how do we compare the modes? Once we think about them, there's 7 continents. Basically, all a mode is doing is saying we're going to make each of those continent points the modal center. Or from a scale degree, we start the scale from that point going forwards, right? So how do we compare the different distances between all the different continents? Well, first you learn the major. Why? Because that's just the convention in Western music, and it's the most useful measurement, and it is also the one that we are going to build our absolute modal numbering system from. But remember, it's just a convention. Theoretically, the Ionian mode is no different. It's just a node in the system. All the nodes are equivalent in the system if you think about it just from a system. So compare the Lydian. So only 1 note difference. Once we know the Ionian, the major scale, we compare the other 2 major modes to it, which include the Lydian, which then only has 1 interval difference. In other words, if I start on the Ionian and I go 1 continent up, and then 2 continents up, and then 3 continents up, and I count the number of oceans and continents or notes between each of those steps, those continent leaps, then I'm going to only have one difference if I do the same thing from Lydian. Starting on Lydian, go 1 continent up, 2 continents up. If I take the same distance from Ionian as I do to the Lydian, I will almost always not land in the ocean. I will land in another continent every time except for one time. Similarly with the Mixolydian, if I take all the distances from the Ionian that land me on a continent, then I will also land on a continent with those distances for the Mixolydian except for one interval. And why is that? That's just how it happened to work out, right? That is why the Mixolydian and the Lydian are major modes, in particular because they have a major third. That's the defining characteristic, which are the same for the majors, and they're all different for the minors, but also they're similar. That's why they sound similar and why they're going to be major, because those distances are what they are. So these changes are clear and easy to track via modal distance. So in other words, if I'm on the Ionian, and that's the major scale, and I go up 1 continent, what's the distance? It's going to be 1, 2 continents and oceans, or 2 notes up. What if I'm on the Mixolydian and I go up 1 continent? Well, it's also continents and oceans too. So if I was to compare and contrast those, we would say for the Ionian, we have a 2 note away major second, which I'd rather call a 2 note away from the Ionian node first modal half step, which we'll get into in detail. But same for the Lydian, a 2 note away major second, which I'd like to call a 2 note away from the Lydian first modal half step, and then a 2 note away major second for the Mixolydian, right? So if I was on the Lydian, we have the same thing. If I go up 1 continent up, which would be the second modal half step, it's going to be 2 notes up. What if I go up 3? Well, if I go up 3, let's start from the Ionian. It's going to be going up 2, 2 modal half steps up, or 2 continents clockwise, which would be the third scale degree if I make that the 1, has a distance of 1, 2, 3, 4 continents and oceans, or in other words, notes. From the Mixolydian, if I go up 2 continents, that would be an XB modal range or a 5-3 modal range. I'm starting on Mixolydian. I'm going to land on the Locrian continent. What's going to be the distance? It's 1, 2, 3, 4. So that's going to be a 4 note away major third, 4 note away major third, 4 note away major third. I'd rather call it a 4 note away from the Ionian node second modal half step versus a 4 note away from the Lydian mode second modal half step versus a 4 note away from the Mixolydian mode second modal half step. That would be a lot more specific information. So if we compare all of these, you can see the distances from each of these nodes are the same, except for we get this weird distance, which is not exactly properly named. That's why it's red here, because it's a 6 note away augmented fourth. We'll talk more about that later. But you also see on the Mixolydian, you have 1 distance from the Ionian. So we learn the Ionian or major and then compare the other 2 to it, which we'll talk more about shortly. What about the minor modes? We then learn the minor mode, which you would think would be the main or most opposite to the major mode, although it isn't, right? It should be the Phrygian, you would think, would be the main opposite. But it does make sense because we like using the Aeolian more than the Phrygian, and the Aeolian has similar properties in that if we compare the Aeolian to the other 2 minor modes, which are the Dorian and the Phrygian, there's also only 1 interval difference. So once I learn the differences between the Aeolian and the major, then I can use the Aeolian as a comparative tool to measure the distances to the Dorian and the Phrygian. In other words, all the distances to go 1 continent up, 2 continents up, 3 continents up from the Aeolian are all the same. They will not land us in the ocean for the Dorian or the Phrygian, except 1 interval difference between them for both of them. Then we can compare the Locrian. The crazy Locrian is kind of like a minor mode because it still has a minor third, but it has 2 interval differences to the Aeolian. It's actually closer to the Phrygian. So you can kind of compare the Locrian to the Phrygian, and then it's got the crazy flat 5. We'll get into that in detail. So modal distances highlight these shifts more transparently than scale degrees. So then on the minor modes, of course, if we went from the Aeolian then, and I go up 2 continents up, or 2 modal half steps, 1, 2, I get to the Ionian. So it'd be an AI modal range. That would be the third scale degree. If I make that the 1, what's the distance? 1, 2, 3. There's a different distance than on the Ionian. So on the Ionian, when I went 2 continents up, it's a distance of 4. From the Aeolian, it's a distance of 3 to get 2 continents up, or the third scale degree. The Dorian is going to be similar to the Aeolian as opposed to the Ionian because they're minor modes. So if I go 2 continents up from the Dorian, then that's going to be a dy modal range, a 2-4 modal range. What's the distance in continents and oceans? 1, 2, 3 instead of 4 for the majors. And then, of course, the Phrygian will be similar, where if I go 2 continents up from the Phrygian, it gets to the Mixolydian, a px modal range, a 3-5 modal range, total distance in continents and oceans, or otherwise notes, 1, 2, 3 up. So we can start to build a table. The tables look intimidating, but once you're able to see the distances and what they mean for the Aeolian, then we can compare the Aeolian to the Dorian and the Phrygian, which will only have 1 interval difference, and then we can compare that to the Locrian. So in other words, first we learn the Ionian major, we compare those to the other major scales, then we compare the Ionian to the Aeolian, where the Aeolian has the most differences because it's the minor scale versus the major. Then we can compare the other 2 minors to the main minor, which will only have 1 interval difference. And then we can compare the Locrian to either the main minor or to the Phrygian, because it's actually closer to the Phrygian than the Aeolian. All right. So summary of benefits. So scale degrees rename the root of every mode as 1, introducing confusion. So a lot of times people don't really see the measurement concept because the scale degrees is somewhat convoluted, making us think that we're basically playing like a different collection of 7 notes, which what you want to do is have a system that tells you clearly, hey, look, this is the same collection of 7 notes if we're talking about the same collection of 7 notes. And when we're not talking about the same collection of 7 notes, when we've moved on to a different collection of notes, that should be clearly, indicated. And so the renaming thing is a problem. So modal distance preserve each mode's identity. So a modal distance doesn't make you rename the route that you are on, which you can still kind of do with scale degrees, but you have to consciously not let the scale degrees force you into thinking that you have a different collection of notes, renaming all the continents, all the modes, because it's the same collection of continents. You don't want to rename the map. So modal building allows directional thinking forwards and backwards. There's a real problem, which we'll see more clearly when we go through practice problems, in going in the counterclockwise direction with the scale degrees terms, because you can't really, some people use negative scale degrees, but it doesn't really work because you should have started on 0. So going counterclockwise becomes a mess. We need to figure out a tool, and we'll figure out how to do it with scale degrees and without scale degrees, which is actually more efficient, so that we can make sure we have a way to name directionality to go counterclockwise. You don't need to reconstruct an entire scale to measure an interval. Just identify the modal node and count the modal steps or half steps. In other words, if I'm in a particular key, like I'm in the Dorian mode, I'm playing in Dorian, and then I'm building a chord off of a different, like the Lydian node, because I'm going to a different chord, then I don't need to, I shouldn't have to think about that other place as though it's a completely different set of notes, as though it's a different scale. And that's what you end up doing if you make it the 1, right? What you should be able to do is say, hey, I'm just on this different node and I'm building a chord, or I'm building a collection of notes off of that point, right? And that'll allow you to still visualize that you're still in the same collection of 7 notes more clearly. So closing analogy. Imagine you're trying to travel across a globe from one continent to another. So we're on the globe, we're going from one continent to another. Do you count every ocean and landmass note distance? So in other words, it's even more simple than that, because we're imagining all the continents are across like the equator on the globe. So we can only go like clockwise and counterclockwise across the continents. So when we do that, we're usually going to say, hey, look, if I'm on continent of the Aeolian continent, or on the Ionian continent, I'm going to go up 2 continents to the Phrygian continent. I'm not usually going to say I'm going to cross this ocean and that ocean, right? We're not going to name it the oceans because the oceans are the pass-through things. We're usually going to name it by the continents that we're going to be continent skipping to. So do you renumber the continents each time you change starting points? So in other words, if we had our collection of 7 continents on the planet, and I went from America, then I went to Europe, I wouldn't say America is the 1 continent and Europe is the 2 continent, but now that I'm on Europe and I go from Europe to Australia, now Europe is the 1 continent and Australia is the 2 continent just because that's where I happen to be, right? That's me-centric thinking. I didn't change the world because I'm in Europe. No, that I'd still, whatever the number system is, I want to keep it static so that all the continents have 1 name. And as I travel through them, I don't need a new map quest, right? I don't need a new naming convention. So, or do you measure from fixed point with consistent units? That's the modal distance. So modal distance equals a stable compass for navigating musical space. What's the takeaway? Modal scale building provides more stability, clarity, and musical insights. So we will not abandon scale degrees or intervals. We're going to bridge the gap between them so that you can use intervals as an imperfect tool as effectively as possible, but also be able to learn the more effective tool if you wanted to implement that as well. Actually being able to go back and forth between them really allows you to kind of get a better grasp of what is actually happening anyways. So it's a logical evaluation in musical theory and especially intuitive for guitarists. So it works for the piano, any instrument as well. It doesn't matter if you were on the piano, even though music theory was constructed with a piano, if you had everything that you had today, they wouldn't build it the same way. They would still do something like this, right? We wouldn't build it saying that everything is off of the 7-note collection and we're going to have sharps and flats based on, right? That doesn't make any sense, even though the piano, the way it's designed, is fine. Right, it's just that's not the way you would construct the system if you had everything laid out here. So adopt modal distances for building scales, and your fretboard will become a map, not a maze.